Hold your breath. Make a wish. Count to 3. Come with me.
Welcome everyone. Thank you for joining tonight's session for C#. So as you can see in the shared screen, this will be a continued session that we'll be having every week at 7 p.m. every Sunday. So today is the very start of these sessions. Thank you for joining us, and hopefully in a few weeks, if not next week, you'll start coding at least with the online training application. And then in the following sessions, we'll look at how to install Visual Studio and the tools that you need so you can actually play with the tools that you can use to code in C#. And then we'll look at more deeper concepts such as design and agile practices for collaborating with teams and architectures and so on. So just like the other sessions that we have in Fibonacc, please feel free to interrupt me whenever there's something that is not clear. And just feel free to do so anytime. And by the way, if you can also mute your microphone if you don't intend to speak, because I can hear a bit of echo sometimes. So I don't know if I'm saying things correctly when that's happening. So please mute your microphone in the meantime. And yeah, let's begin. So I think I think I can still hear a bit of an echo. I just mute a couple of you. Just please let me know if you want to be unmuted. All right. Okay. Great. So the outline of our sessions is we're going to start with the MIT 6001. So today we're going to look at some of the topics which is there. So you can watch this video yourself. Sorry, I can still hear a bit of an echo. Where is that coming from though? Yeah, okay, that's great. Right. So this video, you can watch it yourself. I'll send the link in our Slack channel. So I'll just post it there now so I don't forget in the C# channel. So it's in Slack, in the C# channel of our Fibonacci Slack channel. And you can view this session. It's around an hour and 10 minutes. You don't really need to watch all of it. You can watch just first 50 minutes or 40 minutes. But basically the important thing that is being discussed there are the 3 important things that you need to remember when you're working with languages. And this is something that I think would be very useful for anyone who's starting with programming, and especially with anyone who's starting to learn languages. It can be natural languages, it can be computer languages, because once you know these 3 things, then you can apply these 3 concepts in different languages that you use. I'm not sure how it applies to linguistics for natural languages, but I think it's very similar as well. So the 3 points that you need to remember that you can derive from MIT 6001 are that there are methods in every language, right? So the methods are the primitive types. The method, trying to type for me, then the method of abstraction, a method of combination first, and the method of abstraction. And that was highlighted in that video. Right? So it was very clearly highlighted in that video that you need to think of these things whenever you're shifting between languages. So once you know these things, then you'll be able to map it in your head, when you're dealing with a new language. So you can start with C# for now, and then later you might want to explore Python, for example, or C++. But the important thing is, if you know these 3 things, then you will be able to ask the 3 important questions that you need to ask to start with learning a language. So I'll try to map it with English, right? With English for now, because that's a common language, natural language that we have. So what are the primitive types when we're speaking in English, right? So just to give us a very practical example. So in English, we combine sounds, right? So we a, e, o, u, and then the vowels, and we have the consonants. We have the a, b, c, d, consonants, b, c, d, f, g, h, j. So we combine the sounds. When we know those primitive types, we then combine those sounds to come up with words, right? So you have syllables, and then you have words, and you combine words to form the sentences, and you have sentences that you combine to form paragraphs, and then pages, and so on. So you get more and more complicated or complex structures coming from very primitive structures, which are the letters and then the words, and so on. So that's basically two things that you need to know if you want to speak in English, right? So you have the primitive types and the method of combination. Easily, that's how it is. And the method of abstraction is using those simple constructs to create meaning with just simple words. So if I say bluebird, right? So immediately, what do you see in your head, right? You see a blue bird, right? And a blackbird, the same thing. So you have compound words that you don't need to be completely aware of the meaning behind them, but just by using compound words, you're able to combine meanings and then abstract the details of those meanings using very simple words, right? And abstraction also deals with the fact that you don't need to explore the detail behind a concept, but you know that concept immediately. So by thinking about a microwave oven, you know that a microwave oven heats your food, right? With a control like a dial, for example. But because we use the technique of abstraction, we don't even have to think how the microwave oven does it. You don't need to be aware of the parts inside the microwave oven that work together to be able to heat your food. You just know it's a microwave oven, and that's it. And so that's abstraction. Basically, having the ability to limit the detail that you need to deal with a concept. So in applications, in software applications, which is part of what's discussed in the video here in MIT 6001, it is very important. And it's like the USB interface, the USB port. So if I have an example of a USB cable, I have so many here, just trying to be careful not to pull something that I'm not supposed to. Right, so this USB cable, for example, allows you to interface with any USB device, right? So you don't have to know about the details of the implementations of the devices using this interface, but as long as you abide by this interface, then there's a high possibility that your device will work with your component. So that's very important, not only in hardware projects, but also in software. Because in software, for example, if your application is supposed to deal with Word documents, it's supposed to be able to open Word documents, and Word document can, in a way, can be thought of as an interface, then as long as you abide by the Word document format, then your application should be able to open any Word document without being aware of how the different applications that wrote that Word document are implemented, right? So that is one of the benefits of abstraction. Okay, so if we're going to translate what we just discussed into C#, we're going to go through those. We're going to go through the topics here in this website, which is learncs.org. And every time we're going to encounter something which maps to these methods, I'm going to mention it to you. Or if you think I wasn't able to mention it, just feel free to let me know. And the reason for that is I'd like to ensure that you guys are aware of how we're mapping these things, so that if ever you would like to learn a new language, let's say Python, C#, and so on, then you will be able to know the questions that you need to ask so that you will be able to learn that language as quickly as possible. Okay. Now, there's also a Udemy course. It was sent earlier by, I think, Michael in our channel. Let me just check. If I'm not able to find it, I think I'll just send it after this session. But you can, if you like, you can go through this as a self-study so you can expedite your learning process. And I mean, basically, the goal is for you to be able to program as soon as possible so you can use it in your own projects. And if, for example, you're working on a startup and you're working with a developer, then at least you'll be able to have a background on how he's doing it. So you'll be able to understand how the different parts work together and possibly to contribute in your own projects. So, you're not dependent on the developer who's doing things without your input, because at the end of the day, it's your project, and it would be great if you have background information on how to develop your own projects as well. So, and another benefit, if you go through this, sorry, by the way, we go back to this previous video. If you just go through this video next week in our next session on the 25th, we'll have a mystery game. And I've been mentioning this in the other Fibonacci videos. So I think we'll have, it'll be an opportunity for us to go through the moment in that video in the MIT 6001, which is very related to neural. So if you can just go through this video and you get to answer the question, which I will post in that game, then you will win a Google Cap, right? So I'll just show you a picture in a while, but it's a very nice Google Cap, and I hope you will like it. Okay. All right. So any questions before we proceed to coding, to understand the topics here in Learn CS? Anyone? I think, Sally, you're saying something?
Oh, no.
Okay, all right. All right. Okay, so let us start with the basics of C#. Okay, by the way, we have, the session will be about 40 minutes to 60 minutes. And we'll just try to cover as much as we can. And as I said earlier, feel free to ask me any questions anytime. We want to ensure that you learn as much as you'd like in these sessions, okay? All right, so by using this website here, the learncs.org website, you don't need to install anything on your laptop. So you can use a Mac, you can use Windows, Android, and so on. It's all web-based, and that's a good thing about it, because we don't want to get bogged down by having to install Visual Studio manually in each of our machines. So we'll look at that in another separate session. So I think that will be a good opportunity for us to separate it and ensure that it doesn't slow us down. So we may even do a one-on-one. So because different machines, different PCs may have different quirks. So I can assist you individually to install Visual Studio in your machine. Right. So hello world. Okay. Right. So we're just going to go through what's here. I'll just give you a minute to look at this, to read through this, and let me know if you have any questions. All right. Okay. All right. So I think there's a couple of things that need to be clarified here. The Visual Studio that I'm actually running in my machine, I didn't pay for anything, to be able to run it. If you're working on community projects or open source projects, you don't need to pay Microsoft to be able to use their community version. So I'll just show you this one here, Visual Studio 2017. I don't pay for this. So as long as you're working on an open source project, then you don't need to pay. So that's a good thing because you can use it for learning or for exploring C#, for example. Object-oriented is a topic under method of abstraction. So just like the USB concept, the Word document, it's about thinking of concepts as objects. So objects meaning concepts that are related to one another via inheritance, which is a topic we'll explore later on, and instantiation and other object-oriented concepts such as polymorphism, etc. So it's basically, to keep it simple, it's about thinking of your components as objects that are residing in virtual memory. Okay. And the good thing about C# as a starting point is that it's very similar to a lot of popular languages right now. I'm not very familiar with Python, to be honest, but as far as I know, it's very similar to Java, C#, Java, JavaScript, and etc. But it's a good starting point because it's easy for you to translate it in different languages. Okay, so you may not only create applications as Windows applications. You may also create web applications. So you can create websites, dynamic websites, and you can also create Android apps and even iPhone apps by using C#, using Xamarin. So that can be a separate topic that we can go through later on. All right. So do you have any questions for this before we start the first exercise?
All good.
Cool. All right. There's a chat message. By the way, let me know if I'm not seeing your messages. Yeah, okay. All right. So let's start the exercise. Okay. Right, so let's explain the code here on the left one by one. Right, so the first part of the code here is references, right? This is method of abstraction. Sorry, by the way, I can hear some echo. Yeah, okay, it was my wife, Rose. Didn't mute her microphone. Okay, sorry, that's all right. So the first part here is references. Basically, this is a method of abstraction. So you're calling a component in Windows or in the library. It is actually a library. So it is a library of functionalities which are common to apps or to your software application. So it's just saying that whatever code that you have here in this section, it may or may not reference components or objects inside the system library. So this is a library that you have here. So if you want to get more information about that, you can just Google using keyword C#. Right? So always use keyword when you're looking for something which is construct in C# language. So yes. So using has three major uses. So it calls a library, and you may use it to import types and other namespaces, and so on. So, but you don't need to get deep into that for now. And to keep it simple, you can just think of it as a way to call libraries or to call external components, right? So it's just saying that whatever code that follows uses code or uses pre-existing constructs in this library, okay? Now every statement, so if in English, you can think of a statement as a sentence, right? So a sentence is a combination of words. Now, as you can see here, this using statement is a combination of a number of primitive types. First is the using keyword. The second is the library. And the last, or the reference. sorry. And the last is the punctuation, which indicates the end of your statement. In this case, this is the semicolon. So you can say that this is a sentence, and using system is basically saying or combining the two primitive types, or the three primitive types, and even there's a space here, there's another primitive type, by the way. You're combining these primitive types to say to the engine, to the .NET engine, that you want to use this library in whatever you're about to say to your application after this line. So this is a sentence. As you can see here as well, this line is a sentence, right? You have this method call for this class of this library. So as you can see, all of coding really is just communication. It's just a way for you to communicate with your computer, right? And that's just a way of thinking about it. So this sentence is just telling the app that you want this library, which has a class of console, to write this line, goodbye world. Actually, normally it's hello world, by the way. That's the tradition. I don't know why the creator of this website used goodbye world. So the tradition is, whenever you're creating an app, start with this very simple example, so you know that everything is working. So this is the sentence that we have, right? Now, this is now the method of combination. We're now going to look at the method of combination. So we know two methods of combination. One is for creating references to libraries. The other is for calling a method. So when you call a method, by the way, you reference the class which contains that method. You call the method, and then you pass in a parameter. So it's like telling a friend, let's say console is your friend, right? You say console, if you translate that into human terms, very practical example, you can say, let's say your friend is Joe, right? So Joe is part of Melbourne library. So Melbourne, Joe of Melbourne, I want you to walk, let's say, 10 meters north. So that's just another way of saying the same thing, right? So that's all we're doing. That's all that we're doing here in this line. You're telling someone who is a class of a library to do something, and this is what you want. This is the parameter in that action, right? And that parameter should be enclosed with parentheses, as you can see here. And since this is a string, which we're going to explain too much right now. A string is basically as a data type or a primitive type, which is an alphanumeric or any character. And you can recognize it by the fact that it's enclosed in double quotes, right? If it's not a string, for example, you can say 10 or another number. So that's an integer or a float or something else. But let's just keep it simple for now and stick to the thinking that this method call is just a combination of different types, primitive types, that you combine together to create a statement. Okay. Any questions before we proceed to the higher level form of combination?
Elmo, just one question. Yep. Mm-hmm. Like the classic way to start, saying using system, or there is other ways that you can start, like using another word, or system is like the standard library, or how that?
There are cases when, good question, that is a good question. There are cases when system is actually not used at all. Like if I'm just referencing, actually the reason why system is used here is because system is being called here. This is not necessary, to be honest. And I'm going to test it now if it works. It should not be necessary. and it should work. If it doesn't work, then I'm wrong. Okay. Okay, I think the website is playing with us right now.
Maybe we need a system.
Yeah, let's see. Or I might have to refresh the screen. Maybe it didn't like some of the changes I did. Just give me a second. Okay. So system is something that can be changed. Okay. Yeah. So system can be changed, right? So it can have something else like using system .io. So this is like an input-output component, right? So this is like a parameter in this statement, right? So it can be something else. But what I'm saying is this line is optional because system is already being called here. Does that make sense? I think, Carlos, you're in mute.
Yes, so it's not like a structure that you will always use. It's like, for example, I remember when I was doing HTML back in the years, you always have to start with, I don't remember what was the command.
That's the tags, right? The head.
Yeah, you always need to start with that one. So in this one, it's flexible, so you can start with something else. So it's not, let's say, using system. Or you can put as well using, I don't know.
System.io and so on, other libraries that you want to use. But yeah, it actually, I think the answer to your question is that it really depends on what you're about to use. So if the code that you're going to create does not use system, then it will not be necessary. But of course, if your code requires system, then it will be necessary. Okay. I think we have a bit of an issue here. The website is not working, but that's not a problem. We can go through the topics for now, and then we'll just go back to running it. We can go back to running it in. Thank you. We can go back to running it in Visual Studio itself. But yeah, we'll see. Yeah. Do you have to put semicolon after hello here? No. Yeah, good question. We don't need to because this here is another type of combination, right? That we're going to discuss now after we go through this. So that's actually the next thing that we're going to go through. It's a good question though. And it's not running. Oh, it works. Okay, that's fun. And it worked on the code that I had a while ago. So that's thing with web. Sometimes the timing is not expected. Run again. Yeah, please don't play with us. Okay. It's very slow for you too. Oh man. Okay, I think we might as well go through what we can, and let's not let this delay us any further. If that's fine with you guys, just let me know if you want me to delay it somehow. But I think for everyone's benefit, we might as well go through the topics. Right. So we now understand how we call commands or methods in C#. Now we go over to the question of Nizam. Hello here is a different type of combination, right? It's called a class. Right? And this is a topic which will be discussed in more detail later on. But to give you a quick idea on what it is, this is the object that we were referring to in abstraction earlier. So a class is an object. So what are the classes that you can think of? A class can be an animal. So a class can be a vehicle, or a class is, yeah, I mean, just like in many concepts in C#, it's all translatable into English. So what is a class? You can even just check a dictionary for it. So in basic terms, a class is a set or category of things that have some property or attribute common with other instances of the same type. So a class can be an animal, it can be a creature, anything you want, or anything that you can imagine that you want to create in your virtual world. So if you go to this session, MIT 6001, it gives you an explanation of how software development is like magic, right? Because what you're doing in software is really creating things that you can only imagine and creating a reality out of them. So what are the realities that we have? We have the reality of a social network, which we now know as Facebook, hosting our relationships with people in a virtual space. So it's like Mark Zuckerberg is like a wizard, and he created a universe of social relationships in the internet, and that's Facebook. Another magical activity that was done, or magical project, could be Airbnb, right? There's no such thing as the idea of renting space of a neighbor or someone or a stranger in another place, but you're able to work with that space and book that space so that you can stay in it for some time. But how is that possible that you're able to do that? It's because the magic of the creators of Airbnb created that Airbnb universe in the virtual realm and made it available for you to use in your bookings, right? So you can think of Airbnb, Facebook, and so on as just a set of classes that have been combined together so that you can deal with them in a virtual space, right? So that is a very, very important concept in object-oriented programming languages, which is the class. And you just need to understand that it's an object. And if you want to clarify it, you just go to your dictionary. It's just a classification of things. Right? So again, going back to the methods that were discussed in MIT 6001, this class, this declaration that you can see here, is simply a method of combination, right? So you're combining these primitive types, right? And this open curly braces and close curly braces to declare a classification or a class of objects. So how do you declare that? You declare the accessibility keyword, which is public. So you can just do a Google search for that if you like. Google public keyword class. And you can just add C# for that. So it's just saying that this class is accessible from anywhere, right? By anywhere, I mean any project outside of your own project, any library outside of your own library, and so on. Because you can say that it's private so that it's only available in your own library. Right? We'll go through those constructs later on, not now, because we want to keep it as simple as possible. Right? So this is your accessibility construct. This is the class declaration. So you're just saying, you're just telling your compiler that what is about to follow class is actually a word which identifies the class that you want to create. So if I create a class called vehicle, then what we're saying here is that everything contained within the curly braces is the definition of a vehicle, right? It can be a friend, like a Facebook friend. It can be an Airbnb house, and so on, whatever. But always remember that this method of combination allows you to create a virtual component in virtual space. Okay, so any questions about classes? That's fine. Okay, all right, so we now have we now know what a class is. We now know how to make references. We now know how to call methods. We're now going to look at this thing here. What is this, right? So every class has a method, has two things that we can start with, right? There are many parts to a class, but let's start with two very simple things. Actually, let's start with one, just to keep it simple, right? So this thing here that you can see, main, is called a method, right? A method is an action, right? So main here is basically an action of a person. We could actually rename it to something else like walk, right? And how do you recognize a method? A method will always have parentheses after it. So it's how you tell the computer that this is an action which accepts something, which may or may not accept something as a parameter. In this case, this is a main method, and this is a method that you will see. I'm not sure if this is a trivia, but you should see this in every application that you're going to work with. So this is the first method that will be called by any application. So when you run an application, it will always have a main method. Okay? But to simplify the term, it's just an action. That's all it is, really. It's just an action. So static public here again is a declaration of the accessibility of this method. Static is a bit of a complicated topic, but we'll discuss it later on further, so as not to complicate your understanding in this first session. But yeah, let's defer that. Void is just saying that when you call this method, it doesn't answer back with anything. So that means void. It can be string, for example, so that when you call it, this method will return a string. Right? But let's not go deeper into that. I think that's a rather advanced topic that we can go into later on. All right. So what have we done so far? We have created a class called a person, which has one action, which is main. And this action calls a further action, which is writeLine, hello world. And what does writeLine do? It prints out a word in your output window or in the console, right? So you can see the primitive types involved in this code. So you have each of these words, even the space is a primitive type, I would say. I'm not sure if that's strictly correct, but I would say that that is a primitive type as well. So everything here is that you can see is a primitive type, and you combine them together to create meaning. And then you have abstraction here. So you don't even know how writeLine is printing hello world on this screen here, right? It's just doing it. And you just know that by passing it here, you're able to achieve the result that you expect. Okay, so any questions? Any questions about the code that we have here? Which is not running.
Elmo, what are the parentheses, not like the brackets, but they're not
curly
brackets.
braces? Yep, the curly braces here.
Yeah, those ones. What's the name of those ones?
This is an open curly brace and a closing curly brace.
Yeah. So why they are like in different columns? Is that something?
Right. Yes, good question. Good question. There's actually a joke about this. There are two types of programmers, and it's very after some time, you know, when you get to know C# more and more, it's really funny. You understand the joke. So two types of programmers, curly braces. I saw this meme on a Facebook group. So let's see if it's there. There are two types of people. And this is an ongoing debate since, you know, that I've been seeing in college, right? And a good question that you have there, Carlos. So a curly brace can be positioned at the end of a class declaration, or it can be positioned on the next line. It doesn't really matter where you put it, but the point is that whatever is inside the curly braces, the opening braces and the closed curly braces, that's part of your main or of the line that you have declared here. So in this case, it's an if statement. So we're not going to go through into that now, but you can think of this as the public class declaration that we had here, right? And what we're saying is everything inside the curly braces. So you can see this is under the class person. Now the curly braces here is indented to the right by 5 spaces because we want to differentiate it from the curly braces here, that's all. But this should run if we remove the indentation, right? If we remove it like this should run. The only thing is that it's a bit difficult, more difficult to read. Right. So that's right. So that's why we're indenting it like this. And .NET will do that for you as well automatically. Mm-hmm. Right. So what we're saying here is that whatever's inside the curly braces here is actually under this method here. Right. Okay. Does that answer your question, Curtis?
Yes, and also person is something that is abstract, like the system knows what is person, or you can put anything there.
Yeah, you can put anything. It's bounded by your imagination.
Right. Yeah.
You can create any class. So class is like a universal concept, right? So we have classes for anything imaginable.
So you can put cake, public class cake.
Cake, yeah, definitely. So you can have cake, and you can have what does a cake do? Cake doesn't really do anything except maybe spoil. It's spoiled after some time. What can you do with it? You can increase the temperature of a cake, or lower the temperature, or bake a cake. Actually, bake is like a person action, right? So, right. Okay. Another member of a class is called a property. So one member is the method or the action, and another is the property. So what are the attributes or properties? This can be size. This can be name, and so on. So anything which is related to knowledge about something, that's a property.
Okay.
Okay, but we'll look at that later on.
Cool.
Okay. Any other questions about the first topic of Hello World? Okay. All right. Okay. Let's proceed to the next topic. So apologies, but I think the website is not cooperating with us. So just feel free to run it yourself, and don't be afraid to play around with it as much as you'd like. You won't damage anything, I assure you, because it's all web-based, right? So let's go to the next topic. Variables and types. Okay. So if we go back to the example that we had earlier, and yeah, by the way, feel free to go through these discussions as you want. The text here as you want in your own time. We're just going through. I think let's just go through the code so we can make it faster for you. All right. So if we go back to the topic earlier, which is Hello World, we didn't actually declare a variable there, and the reason for that is because we passed the literal string. We call it a literal string, right? So it's a string literal because it's an actual string that you're passing into your method, right? Now, and just by looking at the words in that description that I told you, you know the meaning immediately, what that implies. So it's literally a string, right? So we don't need to understand anything further in that concept. So a variable, on the other hand, is like a placeholder for an actual literal value. So in this case here, product name could be anything. It's like a holder for actual data. Product here is another variable that can hold any value, like 2019, 2015, and so on. Product price can hold any value that you'd like to declare. So it can be $15, $20, and so on. So that is what a variable is. So let me just write some code so we can test it, and I hope it runs this time for everyone's sake. So let's say product name is Toyota, right? And let's say another, actually, let me make it simple for you. Let's just make it clear what type of variable we're making. So this is, as you can see, a method of combination of primitive types to declare a variable, right? So first you declare the type. It is a string. Then you declare the identifier of that variable, which is product name. And then you assign, you use the equal sign, which is a primitive type. You use the equal sign primitive type to declare a string literal primitive type. And this combination is a statement which tells the compiler that you're just saying that you want a variable which will hold the data value of Toyota. Right? That's all. That's all that we're really doing. So next line is product year. Let's say product year. Again, we're going to use a string literal. Let's say 2015. It's a Toyota 2015. And we're just going to say something else, another sentence or a statement. So product price is, the price is what? Let's say 20,000 AUD. I don't know how accurate that is, but let's just use that as an example. And that's it. You're basically saying that you want the system to write this string, this string literal. I'll do that. You want to write this string literal and combine it. By the way, this is an operand primitive type, or plus, which is, I'm sure everyone knows, that you use to combine two different things in this instance. One is a variable. A variable, again, is a pointer or a container for data. And this operand accepts two things. One is a variable, and the other thing that it's accepting in this case is a string literal, which is product name. So what will happen? Right line will then combine these things because there's a plus here. Right line will then output whatever is inside the parenthesis here, which is the parameter for this method. But before it does that, it does this processing first. So plus combines these two. So it will say product name, colon, Toyota. And then once that is combined, then that is passed into the right line method here. So it will write whatever's been passed into this method here. Now plus, you can think of plus as just another method, and you will see that actually behind the scenes. And we can discuss that in another topic. Actually, I actually coded for 3 years, 4 years before I found out that it's actually a method which is being used in the background. So it's actually doing this in the background. And I didn't know that after 4 years of coding. And what it's doing is that it's just called a syntactic sugar. That's another thing, a term that you will see in coding, syntactic sugar. It's basically saying the same thing for something more complicated. It's like a euphemism, a better term, a more acceptable term for something which is not acceptable. Right? So you can just Google this on your own later on. But basically, this is a more easily understandable version of the other one that I just showed you a while ago. Right? And the same thing is being done in the following lines. Right? So let's run it and hopefully it works. If it doesn't work, maybe we can try it in another machine, or let's just use the expected output. All right. So this is what it will do. Right? So this is like a cheat then. So product name, then TV, product year 20. Okay, it will say 2015 in our case. Product price $279.99. In this case, you'll just have to trust me that it will work. Okay, because we're just cheating to get the output. All right. So that is variables and types. So we have the types here, string, and you have the variable name here, and you have the variable values. And yeah, please feel free to try using the boxes here on your own. I'm not sure, maybe it's just a problem on my end. Okay. Any questions about this topic? Oh, same problem for Nizam. Yeah, it looks like they have server issues. Not a good timing for us, for them. Okay. Yeah, Nizam is just getting the executing message. Please wait. Okay. What I'll do is in the next session, I'll actually run Visual Studio on the side. I don't think we have time for that now, but I'll run Visual Studio on the side so at least we can see it running in Visual Studio. And then in the meantime, maybe you guys can look for an alternative to this website which runs C# code. Okay, let's try and see. Okay, C# online compiler. Compiler. Oh, I think we're lucky. We might be lucky. Guys, you can try it. C# online compiler. Run it. And it works. Genius. Okay, so I'll send this in our Slack channel. Sorry, I'm just excited about that. So I'll send this to you guys so you can play with the code. We don't have to depend on this very unstable online tutorial compiler. .NET Fiddle. If you make the area we are working in to fit the screen, you mean this one? Okay, sure, yeah. Like this? Thanks for that suggestion. Okay. Right, so it works. Right, any questions? Unfortunately, we only have 5 minutes for today. And please let me know if you have any questions so we know everyone understands what we're discussing. Thanks for your time as well, Eva. Thanks. Feel free to unmute your microphones, by the way. We're just going through the summary bit now and just trying to ensure that we are quickly consolidating information. I think you need to unmute your microphone. Rose, did you have a microphone? You can unmute your microphone. Yep.
Do we need to put semicolon in every line on that string?
Like here?
Yeah.
Yes. Actually, good question. No, you don't need to. There's another syntactic sugar which C# allows you to do, but in this version, you can omit the string declarations on each line. So you can just say string, declare your type once, and every variable identifier that you declare will be treated as a variable. So you can say product name, product year, product price, and then you just separate each with a comma. And it will mean the same thing. So if we run it, it will run as expected. So just to prove that it's not a cheat, let's change the value and see that it should work.
What about the last one? It still has the semicolon.
Yeah.
So every...
Yes. Yeah, go on.
Hello.
Hi.
Hi.
What's your name? Thanks for joining us. Hi there as well. So this sentence is just like this. That's all this line is saying. So it's a sentence. It's a statement saying that we're creating a string. These are the strings we're creating. string variables that we're creating. These are the values for each of those variables, and so on. So it's just a sentence, and it's syntactic sugar to separate that sentence into separate 3 sentences, combine those 3 sentences into one, and separate them using comma primitive types.
I think that's nice.
Yeah. It's common even in natural languages. Like in Filipino, we have very complicated concepts, and we just use one word like tol. 3 letters tol. It means close friend. And I'm sure that's present in so many different languages as well.
And can you do the same with this console write line?
No. This is unfortunately there only for variable declaration.
Oh.
Yeah. And that's the problem. That's the problem with existing languages, because, ideally that question, you should be able to answer that yourself by just clicking stuff, right? Unfortunately, that's not available in C# because it's a 2-dimensional language, not like neural. It's a free plug. Okay. Good. Thanks for asking that, Carlos, by the way. All right.
Making more things easier as possible.
Yes, exactly. All right. So any other questions?
Can I do it? Right now. Hello.
Hi there.
She's the new programmer of the group.
Yeah, the youngest programmer of the group, I guess.
She's going to teach you how to do the things, Elmer.
Yeah. Right. So the next generation. Exactly. So Nizam is asking for homework. Right? Thanks for asking, by the way. And that reminds me of the homework that I suggest you go through. So this, again, I can't reiterate it enough. This is very important. And I am a bit sad that I only found this last month when I was thinking of a session for neural. And I should have known this back in 2002 when I started programming. That shows how old I am. But that's 15 years ago. And it's very important. It's very, very important. It's a bit complicated. There are some mathematical topics there that you should feel free to skip. The main parts here are these 3. And once you understand these 3, you'll be like Neo in the Matrix movie. You'll be able to speak any language, I would tell you, and speak it as soon as possible. And consequently, speak to any computer. Yes, programming, and even for I think it has implications for natural languages as well. It's not just for programming languages. And I would encourage you to go through this video. So that would be the homework, and please go through that, so that you can prepare yourself for the game that we have next week. So the prize is a Google Cap, and I hope you like it. All right, so can you copy and paste into Slack? Which one? Yes, it's there. It's now in the C# channel in Slack. So that's the lecture 1A MIT 6001, Structure and Interpretation. Okay, guys. Sorry. Yep, Rose, unmute your microphone. Unmute. Yeah.
Maybe Nizam wants to try a programming exercise, something like that.
No. I think he's asking about the homework for now. I think if you like, I mean, as an offline self-study, just feel free to play with the learncs.org website that I sent in the Slack channel. That would be your assignment, and just on your own time, just play it like a game. And once you feel confident to play with the C# code, and I'm sure you'll be able to learn it as quickly as you can. Oh, the Udemy course. Yeah, thanks for reminding. That was sent by Michael previously. I'll just try to look for that. Unfortunately, I don't have it now. But I'll remember to post it in the channel that we have. Okay. Udemy course that was sent earlier. Unfortunately, yeah, It might not be free anymore. I think it was, yeah, Michael says that it might not be free anymore. It might be free for a time only. So, yeah. But don't worry, we're here. So, yeah, Michael has posted. Okay, Michael has posted the link. So yes, please, guys, grab it while you can. It's a free course. I'm sure it has all the details that you need to understand C#. And yeah, just feel free to join us if there's anything that you find unclear in those sessions. And you could think of these sessions as a way to supplement your own studies in C# language. Okay, so anything else before we close? All right, so I think there are no questions. Thank you very much for joining us today. And thank you for joining us in the C# sessions, and have a great rest of the Sunday, whatever is remaining. We have 4 hours left.
Thank you, Elmer. Thank you very much.
Thank you.
Great.
Thank you, Carlos. Thank you, guys. Bye. Bye. Bye for now.
Bye.
There's nothing to